test probes in industry, and why they matter. In modern manufacturing, test probes are the small contact elements that make many quality checks possible, quickly, repeatedly, and with a high level of confidence. They create a temporary, controlled electrical connection between measurement equipment and the device under test. Whether that device is a printed circuit board, PCB, or a cable harness. In practice, they are one of the most important invisible components in production testing. If the contact is unstable, the measurement is unreliable, and everything downstream becomes slower and more expensive. Across sectors such as telecommunications, medical technology, aeronautics and aerospace, automotive, and many other industrial fields, test probes are used as secure and dependable contact points for PCB testing, ICT plus functional test, and harness testing. Why a test probe can decide pass or fail. A test probe does not only touch a pad, it must do so with the right force, the right geometry, and the right repeatability thousands or millions of times. That is why many probes use spring-loaded designs. The spring compensates for tolerances, surface irregularities, small misalignments, and the natural variation that exists in real production. The result is a more consistent contact pressure, which helps reduce false failures caused by intermittent contact, contamination, or oxide layers, retest loops that waste time and create uncertainty, debugging sessions where the test setup is blamed for product issues or the reverse. In other words, a reliable probe helps protect yield, stabilize test results, and keep production moving. A fast-growing application, charging contacts and pogo pins. Beyond classic ICT and harness test, a steadily expanding use case is charging and power contact for industrial devices. In this context, spring-loaded contacts, often called pogo pins, can act as charging contacts, battery test contacts, or PCB connector contacts, either as single contacts or multi-pole blocks. This is increasingly relevant as products become smaller, more compact, and more frequently designed for docked charging and quick connect interfaces. Main families of test probes used in production. Below is a practical map of the most common probe families and what they are typically used for. ICT probes with aggressive tip styles. For in-circuit test, the challenge is often surface condition. Oxidation, contamination, or coatings can make contact uncertain. Aggressive tip geometries are designed to break through surface layers more effectively to secure contact on pads. Standard test probes. Standard probes cover a wide range of pitches and mechanical formats, supporting both small and larger contacting needs. Selection usually depends on pitch constraints, target pad geometry, available space, and mechanical life requirements. Probes for cable harness testing. Harness testing requires stable contact on pins, terminals, connectors, and sometimes exposed conductors, often with repetitive cycles and workshop variability. Dedicated harness probes are built for safe, repeatable contacting in cable test environments. Coaxial and high-frequency test probes. When signals move into high-frequency domains, a simple contact is not enough. Impedance control and shielding become critical. Coaxial and HF probes are designed to contact diverse test items while preserving the signal integrity needed for meaningful measurement. Pogo pins and spring-loaded connectors. These are widely used for spring contact, charging contact, and modular interfaces. Some variants include solder connections, supporting semi-permanent integration into fixtures or assemblies. High current test probes. When higher currents are involved, power electronics, battery testing, or high current rails, special probes handle higher ampacity while limiting heating, contact wear, and measurement instability. Pneumatic test probes. Pneumatic actuation can help when a controlled approach and consistent force application are essential. These probes are often used when a test setup requires high repeatability or specific mechanical sequences. Interface pins and interface test probes plus fixture customizing. In real factories, probes rarely live alone. They are integrated into adapters, interfaces, and fixtures. Interface pins and interface probes support different adapter standards and allow engineers to build reliable test hardware. Fixture customization becomes a key step to align the probe technology with production constraints. Why probe choice is a strategic decision. Probe selection is not simply pick a length and a diameter. It is an engineering decision influenced by pitch and access constraints, tip geometry and surface condition, required spring force and mechanical life, current and frequency requirements, fixture design and alignment tolerances, maintenance cadence and replacement strategy. A good choice reduces false failures and keeps test results trustworthy over time. A poor choice turns test into a bottleneck. Cotelec's position in test probes. In France, Cotelec is presented as a market leader in test probes and test interfaces, with more than 35 years of activity in this field. This long presence is reflected in dedicated technical content, product ranges, and documentation covering multiple probe families and test applications. How this fits Pacta Industry. This Pacta Industry episode is designed as an industrial press style review. The aim is to explain what test probes do, where they fit in production, and how different probe families match different constraints, while highlighting solutions and product ecosystems available through Cotelec and its industrial network.